Mobile communication systems have evolved over multiple generations from 2G to 5G approximately every 10 years. Each generation has taken a big step and introduced new technologies. The time spent for defining the vision and developing technical standards for each successive generation has shortened from 15 years for 3G to 8 years for 5G. In addition, today's exponential growth of advanced technologies such as artificial intelligence, AI, robotics, and automation will change the future in wireless communication. These circumstances lead to four major megatrends advancing towards 6G's connected machines, i.e. IoT, use of artificial intelligence for the wireless communications, openness of mobile communications, and increased contribution for achieving social goals. It is predicted that the number of all connected devices on Earth will reach 500 billion by year 2030, which is about 59 times larger than the expected world population, 8.5 billion, by that time. Mobile devices will take various form factors, such as augmented reality, AR, glasses, virtual reality, VR, headsets, and hologram devices. Increasingly, machines will need to be connected by means of wireless communications. Examples of connected machines include vehicles, robots, drones, home appliances, displays, smart sensors installed in various infrastructures, construction machineries, and factory equipment. The potential benefits of AI applied to wireless communications are promising. On the other hand, there is a limit to what is achievable today, as use of AI in communication networks was not considered when developing existing communication systems such as 5G. In the case of 6G, knowing that AI technologies are available for practical applications, Samsung is said to develop a system that takes into account the possibility of embedding AI in various entities comprising wireless networks and services. A tremendous amount of data associated with hundreds of billions of connected machines and humans needs to be collected and utilized in 6G systems. Considering AI from the initial phase of developing concepts and technologies for 6G will give us more opportunities to take advantage of AI for improvement of overall network operations in terms of performance, cost, and ability to provide various services. With the unprecedented rate of advances in high-resolution rendering, wireless networks, mobile devices will be able to render media for 3D hologram displays. Hologram is a next-generation media technology that can present gestures and facial expressions by means of a holographic display. The content to display can be obtained by means of real-time capture, transmission, and 3D rendering techniques. In order to provide hologram display as a part of real-time services, extremely high data rate transmission, hundreds of times greater than current 5G system, digital replica with the help of advanced sensors, AI, and communication technologies, it will be possible to replicate physical entities, including people, devices, objects, systems, and even places, in a virtual world. This digital replica of a physical entity is called a digital twin. In a 6G environment, through digital twins, users will be able to explore and monitor the reality in a virtual world, without temporal or spatial constraints. Users will be able to observe changes or detect problems remotely through the representation offered by digital twins. Users will be even able to go beyond observation, and actually interact with the digital twins, using VR devices or holographic displays. A digital twin could be a representation of a remotely controlled set of sensors and actuators. In this manner, a user's interaction with a digital twin can result in actions in the physical world. For example, a user could physically move within a remote site by controlling a robot in that space entirely via real-time interactions with a digital twin representation of that remote site. With the help of AI, digital replication, management of real-world and problem detection and mitigation can be done efficiently without the presence or even detailed supervision by a human being. The peak data rate of 5G is 20 gigabits per second. 5G cannot possibly support such an extremely large volume of data as required for hologram media in real time. To reduce the magnitude of data communication required for hologram displays and realize it in the 6G era, AI can be leveraged to achieve efficient compression, extraction, and rendering of the hologram data. The market size for the hologram displays is expected to be $7.6 billion by year 2023. There will be new advanced services in 6G era, which require a tremendous amount of real-time data processing, a hyperfast data rate, and extremely low latency. These new services can be characterized as providing ultimate experience through hyperconnectivity. Relying only on improvement of the communication link performance does not suffice to realize new 6G services. In order to realize advanced multimedia services such as truly immersive XR, mobile hologram, and digital replica, 6G needs to provide a much higher data rate than 5G. While 5G was designed to achieve 20 gigabits per second peak data rate, in 6G, Samsung aimed to provide the peak data rate of 1000 gigabits per second and the user experience data rate of 1 gigabit per second. To provide advanced multimedia services to a large number of people, the overall network performance needs to be improved. Future applications, such as truly immersive XR, mobile holograms, and digital replica, require extensive computation capabilities to deliver real-time immersive user experience. However, it would be challenging to meet such computational requirements solely with mobile devices, especially given that many of future mobile devices will tend to become thinner and lighter. For example, our glasses should be as light, thin, and small as regular glasses to meet the user's expectations. In order to overcome the limits of the computing power of mobile devices, Samsung considered the concept of split computing that makes use of reachable computing resources over the network. These computing resources could be available on various entities of networks, for example, mobile devices, BSS, MEC servers and cloud servers. With split computing, mobile devices can effectively achieve higher performance even as they extend their battery life, as devices offload heavy computation tasks to computation resources available in the network. The completion of the 6G standard and its earliest commercialization could happen as early as 2028, while massive commercialization may occur around 2030. If you like my video, please like, subscribe and share. Thank you.